Good day to all of you. Today we shall discuss on question number 8a from model question paper 2 with effect from 2022 CBCS scheme of third semester B degree examination of the subject Digital Design and Computer Organization with subject code BCS302. The question is as follows. Explain hardware interrupt, enabling, disabling of interrupts and sequence of events in handling interrupt request from a single device. It carries 10 marks. So first let us see what is an interrupt. An interrupt is a hardware signal sent by an I/O device to processor requesting for a service from processor. So we all know that to processor several I/O devices means input output devices will be connected over the bus. The examples being keyboard, monitor, printer are the most commonly used input and output devices which are connected to processor. So whenever any I/O device wants the service from processor, it sends a hardware signal. Okay, means it sends a interrupt request signal on one of the bus line. That is what is hardware signal. Okay. So the interrupt request from an external device causes the processor to suspend the execution of one program and start the execution of another. Because now processor is requested for the service by I/O device. Now processor was busy executing one program. When it gets an interrupt request, then it causes processor to suspend the execution of current program and start the execution of another program. That another program is the interrupt service routine, means a special set of instructions needed to serve that requesting device. So here we can see program 1 is the compute routine, means processor is busy with some computing related instructions. So at this instruction say I, the interrupt from printer occurs. Then what processor does? Suspends the execution of this program 1. Then it starts executing a special set of instructions meant for serving the printer, that is called as print routine here. Interrupt service routine means a special set of instructions which is meant for serving that device. Here it is printer. So processor will execute those instructions. So it will have served that external device, say printer here. After that it will resume its operation in the main program, that is here compute routine. So here interrupted program is compute routine, interrupting program is print routine. Okay, so after serving that external device which had interrupted processor, it will return back and it will resume its operation by executing next instruction to I. Okay, so before going from compute routine to print routine, that is interrupted program to interrupting program, processor will have saved content of some register, say program counter. Program counter will always store the address of next instruction. So printer was interrupted here at instruction I. So after executing that, it should have gone to I plus 1. So program counter has the address I plus 1. So this address is stored on stack, and then program status register. So for what it had computed here, so at what stage, what was the status of computation, that will be saved by condition code flags in program status register. That is one of the special registers in a processor. So those condition code flags or bits in the status register indicate the status of computation. So along with program counter, the program status register content and other information needed, that will be saved on stack. After that it will have gone to print routine. So at this when interrupt occurs, it will save program counter and program status register content and any other information needed on the stack. Then it will go to interrupt service routine. It executes that special set of instruction needed to serve that device. After completing that, it will come back to the main program or interrupted program. There it will retrieve all the content from stack, that is next instruction address, status register, program status register content, that is the status of computation, what had happened there, and any other information which it had saved on the stack. Hence it will resume its operation by the next instruction in the main program. This is actually what happens when any device interrupts the processor for service from the processor. Here printer was interrupting the processor for service. Okay. Next, what is interrupt hardware? Okay. To serve the mechanism of interrupts. What is the hardware? So here it is the processor. I/O devices are connected through switches to one bus line that is called as interrupt request line, okay, which is connected to processor. Inside there is NOT gate. This is INTR bar. If it is 0, inside it is made as logic 1. So many devices are there. So device 1, device 2, device N, through switch 1, switch 2, interrupt switch N, they are connected to common interrupt request line which is connected to processor. Okay. Then when any device makes an interrupt request to processor, it will close the switch. When this is closed, this ground potential means INTR bar line is made 0. Inside NOT gate is there, that 0 is made 1. So processor gets a logic high signal on INTR line here. That indicates that an IO device is requesting the processor. Okay. So the status of this INTR is the logical ORing of INTR1 or INTR2 or INTRN. That is what is indicated. When any device requests by closing the switch and making this line active, inside processor gets hard active high signal. So that is what this equation is indicating. So this is the hardware needed for interrupt mechanism. Next, enabling and disabling interrupts, that is how interrupt requests are controlled. See, many IO devices will be connected to processor. At any time, any device can interrupt the processor for service. But when a processor is serving a device by executing its related interrupt service routine, that is a special set of instructions meant for serving that device, no other device must be able to interrupt the processor. That is why device request must be controlled. That is what is enabling and disabling interrupts. In the first option, DI, disable interrupt, is the instruction that is made available to programmer also. In ISR, that is interrupt service routine, first instruction will be DI, disable interrupts. Means it will make one bit in the program in processor status register as 0. Means that is interrupt enable bit is made 0, means the interrupts are disabled. No other device can interrupt the processor now. Then processor will have executed ISR. The last instruction in ISR will be made EI, that is enable interrupts. Means that interrupt enable bit in the processor status register which was made 0, now it is made 1. Means again it is made active. That means any other device can interrupt the processor now. Then processor control will be switched back to main program. So it will return from interrupt. So return from interrupt instruction is executed in the ISR. Hence, it will return from ISR to main program. Okay. In second option, processor automatically disable interrupts before starting the execution of interrupt service routine. After saving the content of PC and the processor status register on the stack, processor performs equivalent of interrupt disable instruction. Means here programmer is not doing by giving disable and enable interrupts at the start and at the end of ISR. Here processor only automatically does. Okay. Interrupt enable bit IE in the processor status register indicates whether interrupts are enabled yes or no. When a return from interrupt instruction is executed, the contents of processor register PS are restored from the stack, setting IE to interrupt enable bit in the processor status register as 1. Hence interrupts are again enabled. In the third option, processor has a special interrupt request line which is edge triggered. Processor will receive only one request regardless how long the line is active. There will not be multiple interruptions. Hence, there is no need to explicitly disable and enable interrupts. Okay. Means what interrupt request line INTR bar line we saw in the interrupt hardware. Here it is a special line. It will be edge triggered. Means for only once becoming active, processor will have understood that a device is requesting and it will attend that device. This automatically next, though it is high, no other device can request or interrupt the processor because it is a special INTR line. Okay. So next we shall see what is the sequence of events involved in handling an interrupt request from a single device. Okay. So device is enabled. Assume that device interrupts are enabled. EI bit in processor register bit is 1. Any device can interrupt now. Then a single device, one device is requesting the processor. Then what all events do take place? So first one, device raises an interrupt, means it will close its switch, INTR bar line becomes low. Inside the processor, INTR line is logic 1, that is active. Processor is informed that a device is requesting processor for service. The processor interrupts the program currently being executed. Means processor was in some main program, like in the example we saw compute routine. It will suspend the operation of that or execution of that. So interrupts are disabled by changing control bits in processor status register. This is in case of ordinary INTR bar line. If it is special edge triggered line, then this is not needed. The device is informed that its request has been recognized. Means the device will be sent interrupt acknowledge signal by the processor, indicating that processor has accepted its request. Then it deactivates interrupt request signal. The action requested by the interrupt is performed by executing interrupt service routine, means a special set of instructions meant for serving that device. Then interrupts are enabled and the execution of interrupted program is resumed. So program control is switched back from ISR to main program. Okay. So with this we come to the end of discussion. So in this discussion we saw what is an interrupt and interrupt hardware, the need and procedure involved in enabling and disabling of interrupts, and lastly what is the sequence of events in handling interrupt request from a single device. That completes the discussion. I hope you understood. Thank you.